In this video, I'm going to define what it means for a function to be continuous. Let's say we have a function f of x. We say that the function f of x is continuous at some point a. At point a, if it happens to be the case that limit x approaches the value a, f of x actually is equal to the value of the function at a, that means f of a. So let me try to explain it again. We say that a function f is continuous at a point a if the limit of that function f as x approaches the point a is actually equal to the value of the function at point a, or f of a. Now, a couple of things to remember here. We say that you probably already know from the knowledge of limit that a limit at a point for a function exists if the left limit and the right limit are the same, okay? And it happens to be the same as the actual limit. So left limit and right limit both are the same, and which is actually equal to the limit of the function. So that's true here as well. Also, you may want to notice a couple of other things. Maybe one thing to remember, this f is well defined. F is well defined at a. That means defined, that's what it means. Well defined at point a, and continuous means that the function value at that point is going to be just a limit value. Okay, so limit x approaches a, f of x is going to be actually the value of the function at point a. And of course, we implicitly assume that the limit does exist. Next, we say that a function is not continuous. Not continuous, okay? Not continuous at a point if this limit doesn't exist. So if it is not continuous, of course, the limit won't exist. So that's another thing to keep in mind. So this is called a pointwise continuity, all right? So the function is continuous at one point, or if the function is continuous at each point where it's defined, then we say that the function is continuous in its entire domain. So let's say f is a function. Let's say f is a function. It has domain D and the range, let's say the real number set, okay? So we will say that the function is continuous if f is continuous at each point of its domain. So if it is continuous at every single point in the domain of that function, we say that the function is overall continuous. Now let me give you an example of a function that is continuous. So this is my x coordinate and this is my y coordinate. The y coordinate represents the function value. So here is an example, a graph of a function, right? Y is equal to f of x, y is equal to f of x. It is a continuous function. One way to kind of remember this is that continuous functions are smooth, okay, for the most part, or you can draw them without lifting your pen or pencil, all right? So here is an example of a continuous function. You will see many of the functions that you are familiar with. They are continuous, like exponential functions, polynomial functions, trig functions, etc. For the most part, they are continuous. Here is an example of a function that is discontinuous at a certain point. So let's look at this function, which is defined as f of x is equal to x if x is greater than or equal to 0. So that means from 0 onwards is just regular straight line, which is this. However, for anything less than 0, if x is less than 0, then the function value is -1, which is right there. So there is a discontinuity at x is equal to 0. As you can see, limit x approaches 0 from the positive side, the value of the function f of x is nothing but 0. However, limit x approaches 0 from the negative side is f of x is equal to -1. So the right limit and the left limit, they are not equal, right? They are not equal, so therefore the limit doesn't exist. Therefore, by definition, this function is not continuous at x equal to 0. However, I didn't come up with this example from out of the blue. There is a function behind that. I just modified the original function a little bit to show you that there is a discontinuity right here, right? That original function is this one. Y is equal to f of x is equal to x if x is greater than 0 or greater than equal to 0. X is 0 if x is less than equal to 0, okay? This function is very simple yet extremely useful. This is a very powerful function. I didn't realize it until I started to delve into another field of studies called artificial intelligence or machine learning. This function, by the way, is called ReLU, R-E-L-U. I think that's how they write it. Rectified linear unit. I learned about it. I thought it was kind of like simple function, nothing out of the ordinary, kind of boring function. However, when I started to study machine learning / AI, artificial intelligence, I found out that, oh my God, this function is extremely useful and very powerful. It is probably the closest thing to mimicking biological neurons, how they function, the simplest, in a simple way. So please do remember this function. And you guys are studying math and science, okay? You may want to pay special attention to AI and machine learning. AI and machine learning are synonymous. They're the same thing. So I would strongly encourage you to explore artificial intelligence and machine learning. And this is, at the moment, this function is literally a default function for generating neural networks, which is the heart and soul of artificial intelligence. So please pay attention to this function. And I came up with this function by kind of modifying this. But I want you to know this rectified linear unit. Very simple, yet very powerful function. Anyway, so we talked about continuity definition and what makes a function continuous at a point. We talked about what makes a function continuous in its domain. I gave an example of a function that is continuous, gave an example of a function that is discontinuous at a certain point, and then, of course, talked about very important rectified linear unit or ReLU function, which has significant use in artificial intelligence and machine learning. I hope that this discussion was helpful. Thank you very much.